All right. So in today's session, what we're going to work on is solving a solution to a coupled system, but using Euler's method. Okay. So Euler's method. This is one of the most probable questions in AIHL. And what I'm going to do is that I'm going to show a very simple method to do this using the TI-Inspire calculator. Okay, and please note for this, some basic knowledge of Excel is needed, but even if you don't have it, it's still fine. Okay, let me explain how this would work. Okay, so they've given three variables, x, y, and t. So time would be the t variable, and the first variable x and y, and the second is y. Okay, so in this, what we're gonna do is that first we're gonna save the two functions on the GDC. Now to save the function, there are two ways. So I'll just prefer this one. Always remember, save it as F1 of whatever variables that you are gonna select. So I'm gonna select T, X, and Y. So please note my first variable will be T, second is X, third is Y. So the first is X plus Y sine T. So let's just put it that way. So to save the function, we go to Control and this button over here so that it gives this thing the saving option. What is it? X plus y times sine t. So put it accordingly, x plus y times sine of t. So I've saved the function in f1 of x. Then the second function, I'll save it as x2 of x, keeping the same convention. Okay. And just in case if you forget to put t or x or y and just land up with f of x, please go into a new document and restart. Okay. Do not try to fix what has gone wrong, because that will be more time consuming in the examination. That is not a good way. Okay, because it might consider the previous function itself and will give you an error. Okay, the other one is x plus y cos t. So let's just put it that way: x plus y times cos of t. Okay, I generally use this thing, the angles in radians, and over here time is 0.5. So it's much better to keep the calculator in radians. Okay, done. So I've saved both the functions here. Then what do we do is that we go to insert and make sure that you're using a document, because this thing will not work if you're using a scratch pad. Okay, go to list and spreadsheet. Now this list and spreadsheet is same as your Excel. Okay, and over here for my reference, I'm going to keep the first as t, second will be x, and the third will be y. So once I've named them, then what do we do is that we put in the initial condition. So time is 0, 3, and 4. So let's put that 0, 3, 4. So the initial conditions are put up. Okay, then what are they saying? Euler's method with the step length of zero point 0.1. So the step length of zero point 0.1 means the time value that is there should increase at an interval of zero point 0.1. So over here, what I'm going to do, see, I need to create a formula over here. So to create the formula, what I'll do is that I'll write equal to. Now, the cell number of the previous value is A1. So I'll put it as A1 plus my H value, which was zero point 0.1. All right. Next. For the recursive formula for x, okay, I need the first. Now, this function that was there for dx by dt, I'd already saved it as f1 of txy, correct? So this is the reason why I was so specific about this, t comma x comma y. Okay, so over here what I'm going to do is that according to the formula that we have, I'm using the order book for this. Yes, so xn plus 1 is xn plus h times f1 of this. Now I have chosen f1, the bracket values, I've chosen it a little differently. So I'm going to follow what I have put in. Okay. So xn means the previous x value, and the h is whatever the height that is given for the time. So the step length is zero point 0.1. So that is my h value. So over here, what I'm going to do is that I'm going to put in the previous x value, which is the cell number of B1. So please remember, equal to B1 plus the h value was zero point 0.1 times F1 bracket. Okay, so over here, if you notice, it was t comma x comma y. So I'll put in the values over here. T, which was cell number A1, X was cell number B1, and this was cell number C1. Okay, done. Then the third one that was there, again, this one was F2. Where is it? Yeah, F2 TXY. So let's put it accordingly. So this will be equal to F2, the function. Okay, and then A1, comma B1, comma C1. I made a mistake here. Why? Because over here, this would be yn, right? That is my previous number. So it should be C1 plus 0.1 times this whole function, which was the derivative bit. Done. It shows 4.7. Now, once this much is done, right, what we can do is that uh, press shift over here, okay, and then select all three of them. So keep the shift button pressed and then select all three. Okay, now there are two ways to go forward. If you are much user this thing what we say efficient with the GDC, you can just go on this, because if you see the cursor changed when I went to this corner, because it is asking if I need to continue with the same formula ahead. Okay, so it directly fills it here. But let's say it's very tedious to do it, tedious to do. It's not a user-friendly option. Then go to after selecting all three of them, go to menu, data, fill. Okay, and then just press the down button. There you go. See, in this, the step length that was asked was still zero point 0.5 when t is equal to zero point 0.5. So if you notice, when t is equal to zero point 0.5, the x value and the y values are obtained. Okay, so in the examination, they're not going to ask you very huge values. What they do is that they ask you less values because you need to mention these values, right? And if they're asking you a lot many of the values, what you'll do is that just fill in the first two, three rows that are there, and then put dot 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 and fill in the last three. Okay, even that would work. In this case, you'll have to write down all of them. So yeah, this would be the final answer, the x value and the y value. We can go on and on with this. Okay, and let's check. Yes. Do you see they're also getting the same answer, 3.95 and 8.21. 3.95 and 8.21. Okay, so that's how we solve a coupled differential equation, Euler's coupled using Euler's approximation on the GDC, which is the TI inspire one. For the other one, that is the Cassie and the TI-84. So for that one, you will have to use a sequence formula. Go to sequences and then put in the formula according to these formulae that are mentioned. Okay, so you'll have to use a recursive rule for this. Okay, so I guess that's it for today. Take care. Bye bye.